Again, my name is Ekkarut Viyanit from NASDA. And today I'm really happy to have a chance to share some research activity that have been done as NASDA. And today I'm going to talk about the load-bearing bogie structure in freight wagon. In my talk, I would like to start with introduction, and then I move on to explain you the design concept and engineering of the load-bearing structure or bogie structure, which include material perspective, component manufacturing, and computational simulation. And at the end, I would like to summarize our activity. Regarding to introduction, please allow me to give you a brief introduction of our research organization. As I mentioned, coming from Rail and Modern Transport Research, which is under NSTDA. So we have mission and vision. We want to develop technology and innovation through research and collaboration with transport sector to serve the demand in rail and modern transport. And as IMT, we have two main teams, which are Smart Manufacturing and Maintenance Technology Research Team, SMM, and another team is Intelligent Technology for Mobility Research Team. And this slide, I just want to show you the member of our research center. Totally, we got around 30 staff working as RMT. And as I mentioned, each team have to deal with different themes of research. The first team need to deal with railway industry, and another team conducting the research to serve the needs in the, let's say, last mile connectivity when the people want to travel from the train station to their destination. Regarding to the topic of my today's talk, as I mentioned, I'm going to talk about bogie. And I have thanked you, Professor Ratapum, because he mentioned about local content. And he just said that when we're talking about rolling stock, in Thailand, we are not capable to produce the bogie. That's why in the presentation of Professor Ratapum, it indicates that 0% local content dealing with bogie. That's why we would like to challenge Thai industry to deal with manufacturing bogie. But the bogie for passenger coach is quite difficult. I would like to start with the simple one. That's why we start with the bogie used for feed wagon. And as I mentioned, we are conducting the research. We just set up the research goal that we want to develop Y25 bogie sets potentially employed for feed wagon. So this how to operate the laser. Or this one, okay. Also apologize for that. And we just start the project, let's say, the beginning of July of this year. So we start to design the bogie sets, as you see from this slide. And what is the motivation to conduct this kind of research? Regarding to Thai First policy, we want to increase the Thai industrial capability, and also we want to increase the number of local content in the railway business. sector. So in terms of Volkswagen, there are 4 key components found in the Volkswagen, which include underframe. The underframe, I think Thai industry have enough capability to produce or manufacture. And the second thing is brake system. So we are discussing, Thailand can produce the brake system used for the railway? Maybe, okay. And we need to talk about couple of devices. Okay, I think now there are some research team in Thailand to conduct the research regarding to manufacturing of couple of units. And the most important thing, we want to test our capability to produce the bogie. So that's why we can answer the question about the local content. We want to increase the number from 0 to some number up to 50% or above that. Okay? So, and in terms of the structure of the bogie, it's quite interesting if you want to deal with the bogie of the Volkswagen, because the ratio between loaded and empty ratio of the Volkswagen is quite high. The number is above 5. In comparison to another railway, for example, Tamka, the loaded empty ratio just below 2. And another passenger coach might be around 1, or a little bit more than 1. So, and another thing that I would like to mention here, what is the bogie for the Volkswagen? We should go with conventional one. In Thailand, mostly we use a 3-piece bogie. But in our opinion of the research team, we think that Y25 bogie might be more interesting than a 3-piece bogie. Because this one. So normally 3-piece bogie make up cast steel structure, and with cast steel structure, we are concerned about the defect in the material. When the defect occurs in the material, it can cause the failure of the bogie dealing service easily. And another thing that I would like to mention here, if you look at the behavior of the bogie comparing between Y25 and 3-piece bogie, the safety of Y25 bogie a little bit higher than 3-piece bogie at the various speed. You can see from this picture. And also, when we are dealing with Y25 bogie, you can get track failiness more than 3-piece bogie. Okay? So, and regarding to Y25 bogie, how we can design and what kind of Y25 we should go with. We go with original Y25, or we should go with modified Y25. In the opinion of research team, we thought that it should be better if we go with the modified one. Because the modified one, we can reduce the weight of the bogie set. So, for example, here, so compare between original one and the modified one here. So, we can reduce the weight of the bogie significantly. For example, the number here, you can see that the weight of the bogie allow 4.8 tons. If we use the modified one, the load can be reduced down to below 4 tons. Okay, that's why we think we go with modified Y25 bogie in our research. So we start with the design. So, but as Dr. Vichai mentioned that the research in Thailand, we should not conduct only research in the laboratory. We should consider about the marketing of the research product when we finish. Okay, that's why the process we start from the product design, product manufacturing, product validation, and then product marketing. And we do hope that after the product used in the market, we can get the feedback for improvement of the next generation of the bogie. So, again, we follow, we approach model in our design stage here. So, and in the development, you can see from this upside down triangle. So, because my background is material engineering, we would like to start from the material perspective. And then we step up to the component, and finally, we can obtain the successful system. So, with the material, we start with, let's say, material foundation or micro scale, and move upward to mega scale, I mean the railway application. So, and regarding the material, because we are talking about the load-bearing structure, we need to deal with structural steel. The question is, what kind of steel should be appropriately used for the bogie? Conventionally, we use S355JR structural steel. But in our opinion, if we consider to reduce the load, the weight of the bogie, we need to select higher strength of steel, higher strength steel. In our plan, we are gonna use like S460 structural steel. With this one, we can obtain the yield strength up to 460 megapascal, and the tensile strength can be like this one, 540 megapascal. Okay. How about the price? If we compare between S555, so the price should be around 0.4 to 0.5 euro per kilogram. But if we use this one, I mean S460 ml, we need to pay a little bit more. We might need to pay around 0.6 euro per kilogram. But we can get, some advantage when we use, higher strength steel. So, and then you can learn from this slide what is the advantage, what is the disadvantage. Compare between the conventional one S355 and S460 steel. You can get, the higher strength, up to, let's say, around 30% higher than S355. But you need to pay more. Let's say, around 50% more. You accept or you agree to pay more, but you can reduce the weight of the bogie significantly. Okay? So, and in terms of, because we are talking about, S25 bogie, which classified as fabricated bogie. The fabrication meaning that we're going to use the welding in the manufacturing mainly. So what happened if we conduct the welding in the steel structure? We need to concern about the fatigue property. As you know that, the welded joint or the weldment is the weakest region in the structure. That's why when we conduct, or when we manufacture or fabricate bogie, we need to understand the fatigue resistance of welded joint clearly. So in our research, we're going to conduct the fatigue test of the welded structure. So, and on the right-hand side, this indicates the most welded joint pattern that can be found in the bogie structure, which are chord-shaped load-bearing joint, T-shaped non-load-bearing joint, and the butt joint. So, and also in our research, we need to employ the finite element to explore the fatigue resistant behavior of the welded structure as well. So, and I think the most important thing, how we can predict the lifetime of the welded component. So we can follow this diagram, this one, FAT cast. So if you have interest, you can study in detail by looking at this document, this recommendation for fatigue design of welded joint and components. So I think it's quite helpful when I start to design a bogie. We study how to conduct fatigue test, how we can predict the lifetime of welded structure. So I would recommend you to study this paper. So as Professor Ratapul mentioned, in the railway, we need to consider about the standard. In our research, we follow EN standard, EN 13749, the standard for the wheel set and bogie method of specifying the structural requirement of the bogie frame. And also, because we are using the welding technique to manufacture the bogie, we need to refer to this standard, EN 15085 part 1. Okay. In our design, we study comparing between different models of the bogie structure by using simulation technique. So in exceptional load test, we can find that we can select the model 1 for further development because model 2 and model 3 could not withstand the load condition applied on the bogie. Okay? And then we go further. As I mentioned, we design the bogie frame like this one. The thickness of the steel can be vary depend on the location in the structure. So, but the more thickness of the material is around 19 millimeters for the web structure, for bolster, and so on. And the fan, we use like, a 15 millimeter thickness. Okay? And the weight, as we estimate, should be lower than 1 ton. Just for the load-bearing bogie structure. But we need to have like wheel set, brake system, axle box, and other things to get the complete bogie. In total, we expect that the weight of the bogie should not over 4 tons. That is our target. We want to reduce the weight of the bogie. So, and after we finish the design, the engineering design, we need to conduct the fatigue test. Again, we follow EN standard. And the load pattern that we use in our study look like this one. We need to apply vertical load at the side barrel, vertical load on the side barrel, on the other side, transverse load, and twist. In fatigue test, twist just 0.5%. So with this, we can ensure the fatigue resistance of the bogie structure. So, how to get... Okay, the load sequence 1, we apply the load, as I showed in the previous slide, and twist at 0.5%. This is load sequence 1. And then we go to load sequence 2. Again, we increase the vertical load applied on the bogie structure. And we go further to load sequence 3, according to the load sequence that I show you. So, and finally, we thought that the maximum test state range is around 180 megapascal, can be obtained at the sensitive location on the bogie. But the question how we can reduce this test length, because if we can reduce test length, which means that we can expand the lifetime of the bogie. Normally, the bogie service life should be more than 30 years. That's why we need to conduct the fatigue test by using finite element method. Okay, I have limited time. Now, I would like to conclude my talk. So, as I mentioned, now we are in the new era of the railway industrial business in Thailand. We just want to participate. And we want to develop TRL9 bogie commercially applied in the railway business. If we conduct our research successfully, we wish that we can create technology localization, we can enhance industrial capability locally, and also we can create domestic supply chain. And last but not least, local content, we hope that we can increase the local content in the railway business significantly. So, and I would like to express my sincere thanks to PMUC, who provide financial support to the research. And I would like to convey my sincere thanks to West Coast Engineering Company, who joined the project in form of in-kind and in-cash. Okay? And I would like to thank to all university, King Mongkut University in Thailand, to participate in the project. Last but not least, okay, I would like to express my sincere thanks to my organization, which allow our research team to conduct this research. Thank you so much. If you have any question, I would be really happy. Thank you so much.
Okay, so I would like to ask you about the progress of the project now. So
Okay. Thank you so much.
please update for us. It is quite exciting to see.
Yeah, as I mentioned, we just started, the project at the beginning of July, which means we already conduct the research for 2 months, right? And we hope that we can finish or complete the design within this month. So, and after that, we need to study, dynamic behavior of the bogie attached to underframe under the railway track condition in Thailand. So, and I think it might take another 2 months. So, and then we have 1 month for modification of the design. So, and after that, we can continue with the manufacturing. Okay, the manufacturing process might take 5 months. And after that, we need to conduct, running test on the actual track in Thailand.
So for the scope of the project, how many prototypes bogie that you need to produce?
Okay, we need to produce two sets of the bogie. Otherwise, we cannot attach to the underframe for testing anymore.
Yeah. Okay, good. And then what is the role of West Coast Engineering other than
Okay, may I answer on behalf of West Coast Engineering Company? Actually, as long as West Coast Company is, the famous company in manufacturing of the engineering component and structure. Of course, their role is manufacture the prototype. Okay.
And will this be also under SRT supervision?
Yeah.
Yes,
we
definitely.
just got permission from SRT 2 weeks ago.
Okay.
that they allow us to work with SRT. I would like to convey my sincere thanks to SRT as well.
Yeah, that's
for for that kind of support.
yeah. So SRT will play significant part
Yeah,
in local
right.
content development.
Yes,
Definitely.
exactly.
Okay, good, and that will conclude our session. Okay, and hopefully we will get some good information from both Professor Ratapum and Dr. Ekkarut. So please again give our two presenters a round of applause.
Thank you so much.